This is a video of the first antenna that I made, and the one I took to Florida and had excellent results with. And I thought it might be good just to have a look at it and maybe discuss it in a little bit of detail. The one thing you want to remember is in building anything, safety is of prime importance. So you want to make sure that you have the proper equipment, the proper protective equipment in order to build the antenna. Now, I mentioned earlier that the as you enter into the octagon box, that I had put tape on both sides, and that's about 3.5, 4 layers of it. You don't go all the way in with it because you just want it to penetrate a portion of the way in. Below it, I have the balun, and the balun is 25 turns on a 3-inch coil form, and it seems to work very, very well. That gives you the 18 to 21 feet that most say you do require. So in total, I have on the antenna, and what I had on the antenna when I got the results that I have published is I had 100 feet of wire of RG58, including what is required here to make the balun. If we go around to the back of the antenna, and of course the antenna is situated quite low because I'm just using it to shoot the video, and there you have your connections for your shield and for your core. They're on there. Now the antenna has been set up for 17 meters. So the jumper is set for 17 meters, and the lengths of the arms are. And again, we'll see that the bolt is on the top and the taps are on the bottom, and that works out well. Now when we measure, the measuring stick comes right up against this ledge right here, and that's what you're measuring from. And so we can take a measurement and just show how the arms can be moved in and out. Keep in mind again that we now have a right-hand side and a left-hand side, this being the right-hand side. And if you try to switch them and put them on the opposite sides, then all of this will simply reverse. In other words, this will be on the bottom and your taps will be on the top. Now this will demonstrate how the measuring stick works. You simply slide it over, and then you set it to whatever length is required. In this case, I have it set for 17 meters. Now, we'll just take a closer look at that, and we'll bring it to the end of the antenna. And maybe get even a little closer so we get a good view of it. And we'll slide it on, and then you can get a look here that it is set for 17 meters phone and CW. So the ball comes to the end, to the marker. And again, as I said earlier, I'll give you all those dimensions later on. These are some of the tools, the large tools that I use for making the antennas. This is a drill press. I paid $50 for it, new at Canadian Tire. You don't have to have a drill press, but it is very, very helpful. It does allow you to do, perhaps a better job of the antenna than one might normally do with all hand tools. This is a slide that I use in conjunction with the drill press, made just simply of plywood and some other wood on top. Later on we'll use it, and you'll see how handy it is. It adds to the accuracy of what you're doing, and does help produce a more professional looking result. Here we have the yellow. That is a miter box. Again, you don't have to have one. It is helpful. And in front of that you have a drill. You need a drill that's fairly heavy duty and is reversible. And then the item here is a 1-inch pipe die, and we've modified that very slightly. The modification is reversible, and we'll get into why we modify it later on, and exactly what it's used for. And then we have a vise. Again, you don't have to have a vise, but is it helpful? Yes, it is helpful. It makes for a better job, and it can be used for many, many things. So you can get by with nothing more than hand tools, small hand tools. What I've shown you here just makes things perhaps a little bit easier. And if you don't have them, perhaps you can borrow them. Maybe you have a friend that has them, or go over to his house to do certain parts of the antenna. perhaps the most important part of the antenna is the octagon box, which really does form the center of the antenna. And there are some pitfalls associated with this. Now, when you buy an octagon box, this is a 3/4 inch PVC octagon box, and inside there are stops. There's a shoulder inside, and that's to prevent the conduit, if you were solvent welding 3/4 inch conduit onto this, it prevents it from going through. In other words, it's just simply a stop that prevents you from going further inside than is required. Now, you eventually will use something like this, and it's a circular saw, and the circular saw will go inside and it will saw that off. What I have done is I've taken a 1 inch, because we are using 1 inch tubing. This is a 1 inch aluminum tubing, 6061, what's called aircraft aluminum, and it's 1 inch in diameter. And so we will use something like this. Now, this is a tapered hole, and so what I've done is I've put aluminum tape around it, and what this does, it steadies it rather than allowing it to simply rattle inside. Now, keep in mind that when you put your tape on, if you're going to use tape, and I recommended the aluminum tape versus, say, masking tape, that you put it on in this direction. The reason being is that when you start saw cutting and your bit is turning this way, you're not gonna be pulling the tape off. The tape's not going to be coming off because you've wrapped it in the proper direction. Now, here's a pitfall that one wants to avoid. Here's a good-looking box. It's made by a company called Carlon, and there's one problem with the box, and you may be able to see it. We've already used the saw in here to saw out that, but what the problem is that the back plate, the back of the box, sits higher than the bottom of the hub. So you will never be able to get the conduit to go through, or in this case, the 1 inch aluminum tubing will not go through because it is hitting on the back plate. Now, what we discovered was that this box here, which is made in Ontario by a company called Kraloy, Kraloy, serves the purpose very, very well. So this box, we have used the saw on it, and we've gone through and we did saw out, and you can see we've come right through with it. Now, the important thing is that when you're using this, don't go in too far, because once you do, you're going to be interfering with your tape, and you don't want that to happen. Okay, if you push too far, then what you're going to be doing is rubbing on this tape, and you don't want that to happen. So that's basically it. So what we've done, we've drilled out all 4 sides so that the conduit, or in our case, the 1 inch aluminum tubing, will go all the way through. Now, we've saw cut the top. And when you look at that, you'll notice that it's wider than what you would get with a hacksaw. And the reason is that we've used 2 hacksaw blades. In other words, we just matched up 2 hacksaw blades on one hacksaw, cut through, and created this slot. Now, this slot is going to be used afterwards, and it will have a gear clamp or pump clamp or whatever you want. That's going to be on there, and that's going to be used later to hold this box in place when the antenna is constructed. Now, you can see now, if this was the pole that you were using, that will go right through without any problem whatsoever. You can place this right through here and right through here, and you've got an excellent fit. And then you put this on, and then you can tighten that, and that holds it. It locks it in, as it were. Now, when we look at the back of the box, we have holes that are drilled in it, and we've given a dimension here of 2 1/4 inches. Now, what I would suggest is that you have 2 choices here. And the ones I've built, those holes are drilled right along the center line. If you wish to have your arms tip up slightly, because they do sag after you get the whole antenna built, you could lower these by, say, a 1/16 or an 1/8 of an inch. Now, keep in mind that this is the top. This is going to be the top. And think about the gear clamp that's sitting on top, or the pump clamp sitting on top. So if you drop this hole down a 1/16 or an 1/8 of an inch, that's going to tip the antenna arms up slightly, and that will compensate for some drooping that you may experience. So what we have here, these holes are 3/16, and they were drilled to accommodate these 1024 screws. Now, all screws, fasteners, etc. are going to be stainless steel, with the exception of the standoffs that are going inside, and these are brass. So what we have here is we have these standoffs, which are 15/16 of an inch in height. And here's two of them. We can put the other screw in here, into the back. And again, the length of that is 15/16 of an inch. And we'll just fasten that in there. Now, eventually, these standoffs are going to be used for fastening the aluminum arms of the antenna. On the back, of course, they will form the connection point for your feed-in, your lead-in wire, your coax. And you can take your choice there in terms of which one you decide to make the core and which one you decide to make the shield. But that basically then is your modified octagon box. So keep in mind that there is a step in some of them where the backplate rises. The backplate rises above the bottom of the hub. Those will be of no value to you. I'm sure there's throughout the world there's units that you can buy that will serve the purpose and serve it very well. These are purchased locally from Rona, and they do an excellent job. They're quite strong, so there should be no problem in that regard. And they do have a rubber seal that goes over it. It's gasketed to make it completely watertight. So that really is the octagon box, and everything that has to be done to it in order to get it to serve your purpose as the center or focal point of the antenna. Okay, I'm getting ready to drill the 4-foot arms, aluminum arms that I'm using for my antenna. It's important to keep in mind that I chose 4-foot long arms simply because I could get antennas, telescopic antennas, that would fit on the ends that were 49 inches long. You may discover a source for telescopic antennas that, say, extend 6 feet. If you do, then you can reduce the length of the aluminum arms. So the aluminum arms then could be, say, 2 feet long. It may be more convenient if you're going on a plane with the antenna or what have you. It just makes for a smaller package. But for my purpose, where I'm carrying it in a van, then having the 4-foot long aircraft aluminum is no problem whatsoever. Now, on the ends, I have marked here 3/8 of an inch in. And what I'm going to do, simply because the diameter of the aluminum tubing is slightly less than the PVC conduit that I've really made this up for, this slide up for, I've just put in a piece of printed circuit board on each side that keeps me centered, because I want to retain my center position. So I'll simply put the drill on now, and these are 3/16 holes that I'm drilling, and I'm drilling right through. And so each piece of a 4-foot aluminum tubing, each piece will have a hole drilled through 3/8 of an inch from the end, straight through. Now that takes care of one, and then we'll simply do the other one the same way, and then we'll go into the next step. And again, we put the printed circuit board material on each side, acts as a spacer, keeps everything nicely centered, and we'll start the drill. and that takes care of the initial drilling. I've changed my drill bit. I now have a 5/16 drill bit in here now, and I'm going to put my spacers in. And I've got the ends of the arm, one of the arms that we just drilled out. Our initial hole was 3/16. And now I've got a 5/16 drill bit, but I'm not going all the way through. I'm only going to drill one side. Doesn't matter which side. At this point in time, no problem. We just go ahead and we drill it out. So I'll drill both of them out. And we'll do the same with the other one. We've got it in, we've got our spacers on either side to hold it centered. And we'll just go ahead and drill this one out. Okay, now we'll go to the next step, which is saw cutting these ends. Okay, we're ready for the next step, and we'll just have a look. One side has got a 3/16 hole, and this side has got a 5/16 hole. Now what we want to do is we want to simply saw cut so that we have a slot. And we'll just show you how to do one, and then you can in turn do both. So we just take our hacksaw, and we just do it by eye. It doesn't have to be perfect. And we're through on that side, and then we'll start on this side. There we are. Now we've cut that notch out. So we can use a file or whatever we want to clean that up, and then we'll show you how that slot is used in building the antenna. Okay, now we have slotted both antenna arms, and as you can see, we've left the one hole just the way it was, 3/16, and these are 5/16. And now we'll show how that slot is used, and it's very simple. You simply take your octagon box and you slide it over. You should have the slot at the back in this case. Slide it over, and then it fits in perfectly, and then all you have to do is put your screw into that, and that's one arm of the antenna fastened. I should mention that when you're assembling the antenna, if you find these holes are a little bit tight, those were 3/16 holes. If you find them a little tight because maybe your drilling's off a little bit, you can increase them to 13/64, and you won't have any problems whatsoever. I fastened this one in place, and then there's a screw that would go into this side, and that shows your center post. And you can see now that you're going to put a gear clamp around it, and when you have the antenna installed and used, that gear clamp is going to hold it tight and prevent the antenna from rotating. So that gives you some idea of how that part of it works, and how we attach the arms. Now what I have done is I have, and I can show this in the final assembly, I have put tape inside of here to even get a tighter fit. So and then it prevents also the arms from drooping, and we'll get that in the final assembly. For the purpose of this video, I've taken a piece of 3/4 inch conduit, PVC conduit, approximately 30 inches long. And you'll notice when you buy the conduit, if you buy a 10-foot length, that one end is larger than the other. That's called the bell end. And that's designed so that when you are using it as conduit and you have to add another piece of conduit, you're able to add a piece on without using a coupling. So in essence, that becomes a coupling. Now we're going to cut this off, but we need to save it. And after we cut it off, we will have a look at how we use it. Okay, we've taken that off, and now we're going to take it just a little bit further here. We'll take the miter box out and open the jaws of our vise. And then we simply take the hacksaw and we cut through it. We cut a slit in it. Now, we're going to use this in a few minutes, and it's particularly useful, and you'll see now that with ease we can slide it right over. We can slide it right over the conduit without any problem whatsoever. It opens up slightly, which is fine. So now we'll go into the next phase, which is the making of the actual coil, and we'll just cut off this end piece. So when we start, we're starting with a nice square end. Now we can break those pieces out of there without too much difficulty. And there's nothing exact or perfect about how you cut this, as long as it serves your purpose. So there, we've now got a slot in there, and that will take us to the next part of the demonstration. Now this is a 1-inch pipe die for 1-inch national pipe thread, and if we take our conduit, our 3/4 inch PVC conduit, we'll find that it slips right through, no problem whatsoever. So what we do is we take our die and we modify it. We've removed the 4 screws that were holding it in place. We take the cap off of it. Now what we do now is we advance the 4 dies towards the center, so it creates a smaller circumference. Now be careful, because they are numbered 1, 2, 3, and 4. So counterclockwise they are numbered to give the proper cutting. Now what we want to do is, we have a couple of choices here. We can use, as it were, a number 14 wire and number 12 wire. A number 14 wire is about 65 thousandths thick. What I have been using, and it's somewhere in between a number 14 wire and a number 12 wire, are just plastic spacers that are about 74 thousandths of an inch thick. So what I will do is I will nest them in there. I will push the dies in that thickness, then put the cap back on. Now that'll provide a view of the spacers just taped in place with masking tape. And once we have the cap on, of course, they'll stay in position, no problem whatsoever. Now I'm certain that a lot of what I'm showing you today will not be found in the machinist handbook as good practice, but it does work, and it's worked very well for me without destroying anything. There is that piece that we slit, and that's going to fit onto there, and then it quite nicely fits into the actual die as a spacer to hold the conduit centered. While we're running it through with the electric drill. Now we had a slot that we cut in it. We have a slot that we cut in here. This 1-inch wood bit fits into there perfectly. So you fit the 1-inch wood bit into there. You can slide this back at any time. What it's doing, it's preventing the PVC conduit from splitting, from opening up. We don't want it to open up. So we're going to put our drill in there, and we're going to put the piece of conduit, as you see there, and then we're going to go ahead and we're going to start our drill. And we'll stop there, because we certainly have gone far enough. And now we are going to reverse the drill, and we will bring it out. Okay, I don't own a good reversible drill that has considerable power, But I do have a portable one, which is suitable for extracting and working backwards now that I've threaded the PVC conduit. So that'll give you some idea of just how easy it is to make the coil form. I oftentimes use 5 feet and run 5 feet through at a time. Our next step will be to cut this to the size we need, and then go from there. Now this will provide you with a view of the coil form, or the PVC conduit, which has been made into a coil form. It comes out in quite good condition. And I'll just continue removing that, and then we'll get into cutting this to size and going beyond that in terms of our tap positions, etc. Okay, we've taken the 30 inches of PVC conduit that we turned into a coil form, and we now have it fixed into our slide. This is a 12-inch length. We've created two 12-inch lengths. And this is a 1/16 drill that we're going to use. Now, if you count 11 turns, that's 1 turn, 2 turns, etc. There's 11 turns. At 11 turns, we're going to be drilling a hole through. Then we will consider this to be our 0 point. This is our 0 point. It's just a wire that goes through there. Now, as we move up, this is 6 turns, and this will be 18 turns, 29 turns, 58 turns, and 115 turns. All of these places that we've drilled, we have gone just through the wall of the PVC conduit, which we've turned into a coil form. This one here, this goes all the way through. And when we get into making the coil, etc., we'll see why we need that to go right through. So again, count 11 turns, and that really is your 0 point. And then you have 6, you have 18, you have 29, you have 58, and then you have 115. We will drill the other one the same way, and then we'll get into inserting the wires that will then become the tap positions. And then after that, we will wind the coil. Now we'll need 4 tap points for each coil. And this, I find, is very easy in terms of measuring. I just simply cut them off. I use my vice jaw as my means of measuring and sizing. It's about the simplest thing I can think of in terms of being able to cut the wires and have them all uniform length. And we'll just cut the first 4. Okay, what we're doing is we're putting the pins in, and we have 4 holes, and I've already got 3 of them in, and I'm just putting the 4th one in. And it's just a matter of putting them in just far enough to get them started. They don't have to be in as far as they're going to be. We're just, at this point, just getting them started in the hole. And there we are, we have all 4 in. And now we'll show you how we set them so they're all the same length. Okay, what we're going to do now is we're going to let the vise actually set the depth. We take a nut, put a nut over the copper, which will be our tap point, and then just simply close the jaws in on the vise. So that one's set, and we just continue on, and eventually all 4 of them will be set for the right length. This makes it very, very simple. It kind of takes the effort out of putting them in. You know they're all the same. And after we finish this, we can go on to winding the coil itself. So there you are. They're in place, the 4 of them. The wire is going to go through here and come out. And there's a wire going through here, coming out the other side, and then that will be eventually attached. Now what I'm doing here now, I would consider critical to making a good coil. And this was a trick. In fact, it's more than a trick. It's It's a process by which you make the best possible coils. The procedure was taught to me by Norm Ross. Norm is BE3ETJ. And what Norm says is that whenever you wind a coil so that it doesn't expand and contract out of control in the heat or in the cold, you always take your wire and you pull it. And when you pull the wire, I'm only using a short section here, maybe 5 feet. The actual length of wire that you're going to need for each coil will be around 33 feet. But it will serve to demonstrate what it is we're doing. We're actually pulling the wire, and then when we pull the wire will start to give, and then all of a sudden it will stop. Like it doesn't want to go any further. And when it hesitates or causes you to hesitate, don't pull it any further. Because if you pull it any further, you'll destroy the wire. You'll actually break the wire. It'll yield. But I'm going to pull it now until, and you'll see that the wire straightens right out. There. I'm at the point that it's resisting me now, really resisting me. And you can see what's happened to the wire. The wire now is perfectly straight. Excellent condition to wind a coil. So what I will do now is I will show you the winding of the coil, and I'm only going to do just a small length of the coil, enough to show you how you clean the insulation off the enameled wire. This wire I'm using now is a 20 gauge. I've used 20, 21, and 22 gauge for the coils, and all of them have worked well. So we'll get started, and we'll just wind the first portion of the coil so that I can keep in close range, and you can see what I'm doing, and you can see how I clean the insulation off the wire, and then wrap it around my tap point. Okay, we're ready to demonstrate winding the coil. The hole that we created, 11 turns from the end, we're using that. We have a wire going through it. And now we'll simply wrap it around. And when we're really doing this, and I have the wire held taut, and I'm walking or working my way towards the wire, this goes much easier. But I think sufficient here to give you a bit of an example. The wire will just snap in. It's hard not to wind it correctly because the wire just tracks beautifully. Okay, now I've got to where I would have my first tap point. And so what you do is you take the wire, and I'm using this tool which is meant to remove insulation, and you just kind of scrape it. Don't go any further than you have to. And after you've got it as much as you're going to get off with that tool, just take some emery cloth and do a real good job. If you don't, it's going to come back to haunt you. Make sure that you've got it nice and clean. Now what you do is you just continue on, and then you wrap the wire around the post. You wrap it around the post. When you have it wrapped around, find your way back into the groove and keep going. And just continue in the same manner until you get to the next one. Now what I'll do is I'll set this up in the vise because I wanted to show you the next step when you have all this completed, and it's soldering. And there's a way of soldering these that I think makes life very, very easy. And we'll have a look at that. We'll just put it in the vise, just enough to hold it so it doesn't try to unwind itself. Okay, what I wanted to mention about soldering is I don't solder anything electronic without liquid flux. This is a hypodermic needle that I have that's filled with flux. You use very, very, very little of it, but it does a marvelous job. And so I would just squirt a tiny bit of flux, as you see there, onto that point, and then I would solder it. And I end up with a beautiful connection, nice and shiny, and I don't have problems further down the road. So I strongly recommend it. It makes for a very good connection. You're wrapped right around the post, 360 degrees plus, and you won't have any problems later on. And the tap points become very rigid, very secure. Okay, here's a completed coil, and you can see the 4 pins sticking up that are used for our tap points. At each end we have used the heat shrink tubing, helps to keep the coil tight. And at this end, which was the 115th turn, if you recall, from when we're drilling our holes, and that is the one hole that goes all the way through, and you can see the wire does go right through and comes out, and that will connect to the arm, to the aluminum arm a little later on. At this end, we have the point at which the telescopic antennas will connect. They'll fit right over that bolt, and we'll get into that in a few minutes. So these pins are about 5/8 of an inch long, and of course we, as we demonstrated earlier, we put a nut over them, we press them in, and there's about 3/8 of an inch sticking up when we're finished. So 5/8 of an inch of number 14 copper wire, and when we're finished there's about 3/8 of an inch sticking up after they've been put in place. So now we'll get into how this cap is made and what it's made from. These plugs will form the end caps onto which the telescopic antenna will attach. Now you can appreciate that you want the hole right in the very center, and there's a nib on the top of this which makes life a little bit difficult. This is what we're going to do. We're going to start by cutting this piece off. In other words, the ferrule end, this will go, and we'll put it in the saw, and we'll just cut these ends off, leaving just this portion here. We have cut the excess off of both of the plug caps that will go on the ends of our coil. You'll notice that there is a nib on the top, and that creates a bit of a problem, because what we're trying to do is to have a perfectly centered hole because the tolerances are so close. The solution I came up with was in finding a nut that fits perfectly into the plug cap. Now what I have done, and I will just sort of reenact this, I then took and I put the nut into a socket, and then I took my vice grips and I started the drill, and I simply drilled out the threads in the nut. And in doing so, I've created a perfect guide that I can now use for drilling out my end caps. And we will demonstrate that. I'll just bring this into position, and that should give us enough room. And I'll take the end cap, the one end cap. I will put the nut in, which now has the threads removed, and put it in position. We will simply hold the plug cap with some channel locks, and now we're ready to drill that out. Now you'll see the end result is a perfect hole. It's perfectly centered, a 5/16 hole, and that will now serve us with respect to putting the bolt through to which the telescopic antenna will attach. In this next step, I'm going to be using a 5/16 a ring terminal on each end of the, or in each cap I should say. What you want to do is you want to cut off the plastic insulation, because that will only, the insulation will get in our way, and that can be easily removed. And there we have it off. Now the next step is to take the terminal and put the nut on, and we're going to snug this up such that we then take the connector and we rotate it as required, so that we are lined up. We're lined up with the flat of the bolt head. We want to be in line, because what we're going to do now is we're going to fold that over. And it'd probably be easiest to just simply take it and put it in the vise. After we restore its position here. Okay. And we'll just use the vise to squeeze it and bring it into position. The ring terminal is on there properly, and you can see it is folded over and tied up against the top of the bolt head. And we're going to take it apart now, and we're going to simply insert it into our cap. Now, we've checked it, it's fitting, and it's fitting well. So there shouldn't be any problem now going on to the next stage. And what we will do, we're still using our mock-up, and I like to be consistent in my measurements and how I do things. And so we're simply going to take this board, which I've used on many occasions just as a means to measure, and we're going to cut the wire off so it is a consistent length. We'll do the same on the other end. There is some importance to this in that that wire also forms part of your antenna. So anything that you do here with this wire in terms of its size, its length, that also it's part of the length of the antenna, and to be taken into account. Now, what we would do is we would clean all this off nicely, and I'm not going to do that because this is just a mock-up. But then you would take your crimping tool, and I guess the easiest way is just to put the device on, put the wire in, and then crimp it. So the wire would have been cleaned, and there would be no problem soldering it. And of course, for soldering, we're going to use the same approach, whereby we use the liquid flux. Okay, now we have that on there, and it's on there quite secure. Not as secure as it would be if I were to have soldered it on. And now we can just take and insert it through and into the end cap. Now, we have enough of the bolt sticking out that we can now take and tighten up the nut, and that will draw the bolt through and into position. Now, I'm sure it'll get to a point here where it will resist, and I will use the channel locks on it right now to simply hold it so I can finish tightening it up. So as we're doing this, what we're doing, we're drawing the bolt and the connector, and we're drawing again. Now that's quite tight. That should not be a problem for us at all. We might be able to see inside our connectors inside of there. The bolt and everything is down. It's in position just the way we want it. What you can do when you're doing your forms, and before you even wind any of the coil, you can sand inside. You can also sand the outside of this. And if all that had been done, and this was the real installation, what we would do, we'd put glue inside of here, and we would put glue on the outside of here, all the way around. And you simply take that, and then you push it in. And in a very short period of time, the glue will set, and we have a permanent connection at that point. The antenna, the telescopic antenna, will then fit onto here. And what I have found using these, the set screws are still in place. They're tight, so we're not going to be able to turn it all the way on. But when you loosen them off, just turn this as if it was threaded, and it will slide all the way on. You'll have no problem whatsoever fitting that on. Of course, this assembly is still loose because we haven't solvent welded it. But that'll give you an idea of how you put the end caps on, and it makes for a very good installation. Now, when we look at a finished coil, and we have previously, there's what you're looking at. There's your piece that you just put in there, and you've connected it up to this wire here that goes through into there onto your connector. This piece here is going to go onto the aluminum arms. Now we're reaching a point whereby we have to identify the arms as to which we're going to call left and which we're going to call right. What I've done is I am putting a 4 rows or 4 turns, and that's my first one. I've made a mark here, so I have that as a reference. There's a mark, so that's 1, and that is 4. So we're right on the mark, and we can cut the tape off at that point. And then we'll go into the next phase, which is putting the couplings onto the arms. And the couplings should fit right over the tape, and we should be able to, it should give us a good fit, and it does. And I'm just going to put this on the floor, and I'm going to tap. I'm just going to tap this on the floor in order to get this all the way in. We have reached the point where we have to identify which is the left arm and which is the right arm. And I think the easiest way to do it is to just simply attach it to the octagon box. And we know that the top, which has the clamp on it, the gear clamp, that is the top. And so we think of the this as being the front. There's no cover in place, but we think of that as being the front. So what we've done is we have this ready now to drill a hole, and we're going to drill a hole right at this point here, and we'll give you the measurements on that hole. The stop inside this coupling is of course halfway, and halfway is 3/4 of an inch from here to here or from here to here. So therefore we've marked this spot, which is 3/8 of an inch. This is an 11/64 drill that we're using, and we're going to drill our hole. And as we said earlier, we have identified that this is the left arm of the antenna, and we will mark it once we complete drilling it. I should mention that we have our little pieces of printed circuit board material in there also to stabilize it. Now we have drilled through the PVC coupling, and we have drilled through the aluminum tubing. And earlier we showed how we put the electrical tape on, 4 turns of electrical tape, and then tap that down into place so we have a good secure connection. I still have it on the left arm on the drill press, and I'm going to show you how to insert. These are 832 bolts, 3/4 of an inch long, stainless steel of course, and you just slide it through and into the opening, and then you can put your finger in and you can actually lock it in position. And then you take your flat washer, again all of this is stainless steel, followed by your lock washer and your nut, and you simply tighten all that in place, and you won't have to hold it inside. It will hold itself and get it nice and tight, because you are making an electrical connection, and that is that portion of it complete. Now we'll go a step further and we'll put the arm on. What you've got is you've got the bolt at the top. Now we're going to put our jumper on, which allows us to change bands. And what is important to note is that we've put this bolt on top, but the taps will be on the bottom. And the logic behind it is that if you have this antenna, say 7 feet off the ground, and you want to change taps, it's more convenient to have the taps on the bottom. The advantage to having the bolt on the top is that it allows the jumper cable to sort of lay on top rather than the whole jumper hanging down. So that's why it's been done that way. We now have a completed coil, and I've got it sitting just inside the electrical coupling, and I can pull that out without any great difficulty. What is going to happen is we want to have these points facing downward, this facing up to connect to there. So you will solvent weld it. You will take your PVC cement and make sure it's PVC cement that you're using. It's good to sand the inside of the coupling in order to get it prepared for the glue. And then you would put the glue on to solvent weld it, and you would push this in as far as it will go, making sure that the taps below are facing directly down. You then clean this wire off. We can put a lock washer, or excuse me, a flat washer. And then we can put a second flat washer, followed by a lock washer and a nut. And now we will simply tighten all of that down. Now, we have a good electrical connection in there. If you want, you can use your own meter and ring it out. Keep in mind that when you make up your jumpers, and we'll get into that a little later on, make sure that they are copper. These are pure copper. They're not copper plated. So your jumper would go something like this, and perhaps to this jumper down below. And that is your jumper in place. Now, what you have to remember is that your jumper is part of your antenna, and you make that a specific length. That jumper is used on all bands except 40 meters. 40 meters, you do not need the jumper. Now, I'm just going to sit the end. This is the telescopic antenna, and I'm just going to sit the end onto the bolt to give you some idea. I have not loosened the set screws, and when you do put that on, you kind of give it a twisting action, and then it will go on without any problem, and then of course you can adjust it accordingly. Now, to make the other end of the antenna, it's the same procedure. The only difference being that you make sure that your arm is facing the right way when you drill the holes. We have put the right arm onto the antenna just to show how it then connects in, and the left arm we have pretty much completed. We have drilled the hole in the coupling, placed the tape around it, make sure 4 turns prior to putting it in place, and then we've discussed the jumper. These are the jumpers. This is one of them. Again, I'll repeat, those are solid copper. I got them through one of the American mail order firms. And the wire is just a speaker wire, one strand of speaker wire. The length of wire from end to end measures 13¼ inches. From the tip to the tip spread out is 14½ inches. Important to keep those figures in mind, because this here is part of your antenna. When you have the jumper in place, this jumper adds to the length of the antenna. And again, jumpers are not required on 40 meters. This is the measuring stick that I use for setting the lengths of the telescopic antenna. And this is just a piece of 3/4 inch PVC conduit, 3 inches long. I've cut a 5/16 slot in it, and then counterset screws into it to hold that in place. And that, we'll see that demonstrated. That goes over the end of the telescopic antenna and sets your lengths. This is just a piece of 3/4 by 1 inch stock, And if you look, and we'll start here where it goes over the antenna, if you look, you'll see how it is marked off. The first mark is 10 meter phone, 15 meter phone, 15 CW, 10 meter CW, and it continues. I will give the exact dimensions that you need. And again, keep in mind that any of the dimensions in terms of the lengths of the telescopic antenna are reference only. They should be fairly close, but you may change some length slightly, and that will necessitate you changing the length slightly. At all times, I think you need an antenna analyzer on the antenna to make sure you get optimum results, because the SWR should be very, very low with this antenna. On the back of my measuring stick, I have just placed this sketch that helps in terms of setting the antenna. And you see this is the whip end. So this would be your telescopic part of the antenna. And your first tap point is for 10 and 12. The second is for 15 and 17. Next comes 20, followed by 30. And of course, as we said earlier, there is no tap required for 40 meters. So again, that's something that you can put on the back of your measuring stick, and keep in mind that what you do on one end, you do on the other end. So the jumpers would have to be in the same position, and the whips extended the same amount. Several people have asked me how I make my trap for my semi-vertical trap antenna. It's a 7 megahertz trap, and it's so similar in terms of the method used to make the coils. I thought I would include it. This is a 4.5 inch length of 3/4 inch PVC conduit, which of course has been machined exactly the same way. And on here I have number 20 wire. There's 31 turns of it there. And what I do is I take a piece. Now this is a scrap piece that has already been through the process. I take a piece of 1/32 printed circuit board material, double-sided printed circuit board material, which has a dielectric strength well beyond anything we're going to use for amateur radio. And I cut it to a length of approximately, this here is 1 3/4 inches, and a width that will fit inside without any problem. So it's smaller than 3/4 of an inch in width, just slightly less. And then I make sure that all the edges, there's nothing hanging over the edges. The edges are all clean. You don't want any little pieces of copper hanging over the edges and causing a problem. Now, once you've done that, you're ready to take and test it. So you connect up the ends. This one here, the capacitor leads are a little short, but I can demonstrate. So you clean the ends, and you solder the ends. And once you've done that, you get your dip meter, and you determine what frequency is the trap frequency. And what you can do is you can trim off, as required, trim off copper, off the copper printed circuit board, trim some off of it until you get to the desired frequency. Of course, if you trim too much, then you have to start off with a new piece of printed circuit board material. But you can trim it, and you can get it very accurate. Now, I should tell you that this now has been treated and dipped in hot glue, and when you do, it does change the frequency slightly. You may want to make one a mock-up and then try it, and if you have a problem, then take another piece of material and trim it, and then allow for what the differences are going to be once you have dipped it in hot glue. And of course, when you do, it's basically hermetically sealed. You shouldn't have a problem with it. I do not put end caps on. This is the way my trap will hang from my antenna, and it's been up there for years now, and I've never had a moment's problem with it. So once you've got it, and you've got it to the desired frequency, and I might say that there is a circuit on the internet that I have used, and it works great with my antenna analyzer. It consists of a couple of resistors and a capacitor, and you can, I think, take basically any antenna analyzer and use it basically as a dip meter to determine the frequency of a trap like this. So now that you've got the printed circuit board material to the size that you think would be ideal, you take some hot glue and a container such as this, and you get as far away from houses, people, and anything that will burn. And I use my my barbecue, and I simply melt the hot glue, and once it has melted and I got a puddle of it sitting there, then I take my high voltage capacitor and I dip it in it and I lift it out. I don't leave it in too long because the temperature can be high enough that it'll actually melt the solder. If it does, you can resolder this without taking the hot glue off. You just put your pen type, your soldering pencil there, and it will definitely reconnect. No problem at all. Good joint. You won't have a problem with it. So basically that's it. Now when you have it set for the proper frequency, then you simply cut the leads to a required length, and then you put a connector on, an eyelet connector, and then you just take these wires and you twist them inside and you connect them up inside. In other words, you would take the bolt out and then slip the bolt right through your connector and then bring it out and then tighten it up, and then again it's ready to go. It's ready to be put onto your antenna. Works well. I've had no problems, and if anyone needs any further details, I'll be happy to provide them. I cannot stress enough the safety factor. Do not do this in your home. Do not do this on your oven. Get as far away from your house as you can get with it. You don't want to be near anything combustible. I have had no problems doing this, and don't overheat the glue. Just heat it to the point that is necessary. Now, hot glues come in different temperatures, and I would suggest that you get the low temperature hot glue if you intend to make up your own high voltage capacitors. I have, on some of my semi-vertical traps, put a capacitor at the bottom that I've made, which is in the range of 25 picofarad, and use the same process, just dipped it, and it becomes hermetically sealed, and it weathers extremely well.